Now let's continue with the VTP. So VTP, simply it is VLAN trunking protocol, guys. That is a Cisco proprietary protocol used to manage VLANs across a switched network. Okay, so the main purpose of VTP is simplifying the VLAN management by allowing switches to share VLAN configuration information automatically. Okay, that's a great protocol. It operates in three modes: server mode, which can create, modify, and delete VLANs; client mode, which receives VLAN information but cannot make any changes; and transparent mode, where the switch does not participate in VTP but forwards the VTP messages. So the benefits of using the VTP protocol is reducing configuration errors, and it ensures VLAN consistency across all switches in the VTP domain. Okay, so let's have a look. A VTP server that is a mode in VLAN trunking protocol that allows a switch to create, modify, and delete VLANs within a VTP domain. Okay, so VTP servers can create and manage VLANs, which are then propagated to other switches in the same VTP domain. Also, changes made on a VTP server are sent to VTP clients and transparent switches to ensure all switches have the same VLAN information. Each time a change is made, the VTP server increments the configuration revision number, allowing switches to determine if they need to update their VLAN information. So, in a VTP domain, the VTP server plays a central role in maintaining VLAN consistency and simplifying the VLAN management across the network. Okay, so you can propagate the normal range VLANs, which are between VLAN 1 and 1005 with VTP protocol. But if you want to propagate the extended VLAN range, which is between 1006 and 4096, you need to use VTP version 3 protocol. So again, VTP modes, we have three modes. They are server, client, and transparent. Okay, a switch might be configured in three different VTP modes. The server again can create, modify, delete VLANs and advertises VLAN change to all other switches in the domain. Client mode receives the VLAN information from the VTP servers but cannot create or modify the VLANs. Okay, they forward the VTP advertisements to other switches, but they don't make changes itself. Okay, they are suitable for switches that need to be part of the VLAN configuration without making the changes. And VTP transparent mode, the switches which are in transparent mode don't participate in VTP, does not advertise or learn VLAN information from other switches, but they can create, modify, and delete VLANs locally. But again, these changes are not propagated to other switches. Okay, the use case for transparent switches they are useful for switches that require local VLAN management without affecting the overall VTP domain. So, in summary, server full control over VLANs, manages VLANs for the entire domain. Client receives as well as forwards VLAN information but no management capability. Transparent local VLAN management capability, does not participate in VTP communications but forwards VTP advertisements to other switches. Okay, they are very important 3 modes that you need to be aware. We have 3 different versions of the VTP protocol: VTP version 1, 2 and 3. VTP version 1 introduces VLAN management and propagation. It supports VLAN IDs between 1 and 1005 and lacks features for extended VLANs. VTP version 2, it adds support for token ring and improved handling of VLANs. So that introduces VTP pruning, which optimizes the bandwidth by not sending unnecessary VLAN information to switches that don't have those VLANs. And VTP version 3, it supports up to 4094 VLANs, including the extended VLANs. And it introduces enhanced security features like VTP authentication and the ability to manage multiple VTP domains. So it can operate in mixed environments with VTP version 1 and VTP version 2. So in conclusion, VTP version 1 is for basic VLAN management and cannot be used for extended VLAN ranges. VTP version 2 has some enhanced features, supports pruning and the token ring. VTP version 3 provides full VLAN support with security enhancements and better management capabilities. So, the configuration revision number, okay? The configuration revision number in VTP, that is a value that tracks the version of the VLAN configuration on a VTP server. Okay, so it indicates the current state of the VLAN database and helps switches to determine if they need to update their VLAN information. Okay, so the number increases each time a change is made to the VLAN configuration on a VTP server. This could include adding, modifying, or deleting the VLANs. When a VTP client or transparent switch receives a VTP advertisement, it compares the configuration revision number with its own. If the received number is higher, the switch updates its VLAN database to match the server's configuration. Okay, so the initial configuration revision number is set to 0 when the switch is first configured as a VTP server. So let's speak on the image. For example, I have my VTP server where I can create, delete, modify any VLANs, right? Let's say I have my VLAN 10, 20, 30 configured in this switch. Okay, and what will happen? This switch will forward this information to the VTP client switches as well. So what will happen? These switches will automatically create VLAN 3020 and VLAN 3020 again on their configurations. Okay, when you create those VLANs within the server switch, you don't need to go ahead and manually create those VLANs in the client switch, because our VTP protocol will do the magic. Okay, so then let's say when I have this VLAN information, I have the revision number of 16 with my server device. Okay, then I am doing some changes. Maybe I'm adding VLAN 40 within this switch as well. Then what will happen? The revision number will be increased from 16 to 17 within the server switch, and this VTP information will be shared with the client switches. And client switches will have a VTP packet specifying revision number 17. Oh my god, revision number 17. I have the revision number of 16 only. Okay, then switch will check this revision number 17 packet and it will see that some additional VLAN, VLAN 40, is added within this VTP update, then the client switch will add this VLAN 40 to its VLAN database again automatically by comparing the configuration revision number. And I just want to give you one more example in here, since we talked about the transparent switch as well. Let's say I have another switch in here, okay, where it is configured as a transparent switch. When this switch VTP server sends the VLAN information to the client switches, where the VLAN 10, 20, 30 and 40 is included inside, this transparent switch will forward all those information to the client switches, okay? But this transparent switch will not update its own VLAN database with 10, 20, 30, 40, okay? Whatever switch, whatever VLAN ID it has already, let's say it has VLAN 5, 6 and 7, it will continue to have VLAN 5, 6, 7 still, but it will forward the traffic for VLANs 10, 30, 20, 40 to the VTP client, okay? But it will not update its own VLAN ID database. So, guys, VTP uses three main message types for communication between switches, okay? And they are summary advertisement, subset advertisement, and advertisement request. Summary advertisement is sent periodically by VTP server to announce the current configuration revision number and VLAN information, and that is typically sent every 5 minutes or whenever there is a change. Subset advertisement contains detailed information about specific VLANs, including their IDs and names, and they are sent when there are changes to the VLAN configuration, for example, like adding a VLAN, deleting a VLAN, modifying a VLAN. And we have the advertisement request. They are sent by VTP clients. On the screen you are seeing switch 1 as the server, switch 2 as the VTP client, by the way. And advertisement request is sent by VTP clients or transparent switches to request the latest VLAN information from servers. So they help synchronize the VLAN database when a switch joins the VTP domain or after a configuration change. How I am doing the VTP configuration, that is very easy to configure. Okay, so for example, let's say you have one switch, you are in the config mode, you type VTP mode and you type the mode of the switch that you want to configure. For this example, I'm configuring a server. So then once you configure this, the iOS will set the device to the VTP server mode as soon as possible. Then I'm setting a VTP domain and the domain name, which is network L. Okay, so only the switches within the same VTP domain will share the VLAN information coming from the server. And then I am setting a VTP password for just, security enhancements. Okay, VTP password, and I'm setting the password that I want to set. That is it. How I can verify, on the other hand, my VTP configuration? The command I'm using is show VTP status. Then you could see the VTP version, which I'm using, VTP version 2 for this example. And you could see the operating mode of this switch, which is server for this case. You can see the VTP domain name and any other protocol related information such as peering mode, v2 mode, etc., it will be displaying in this show VTP status output. All right, we are coming end of this section also. Thank you so much for joining me and listening to me, and let's meet on other lessons.